Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about regex, regular expressions, backreferences. I'm going to open up my web browser to my website, javacjava.com, select the menu and then regex tutorials. Scroll down here to regex backreference tutorial. Now, what is a regex backreference? Well, backreferencing is all about repeating characters or substrings. Now, there are occasions where you may want to isolate repeated substrings or characters within your search string. Backreferences work in conjunction with capturing groups, right, to perform subsequent pattern matches. You might be going, what? It's difficult to explain in words, much easier to explain in source code, which I'll be doing in a minute here. So you will match the first occurrence of your regex with a capturing group, and then you can use backreferences to automatically locate subsequent matches. There are two types of backreferences, numbered backreferences and named backreferences. I'll start off with a simple example. Consider my grocery list in the string literal, apples, bananas, and Tootsie Rolls. Now, what are the characters that repeat in my grocery list? Well, here's a couple of P's, here's a couple of O's, and a couple of L's, okay? Now we can write a regex to find these repeating characters like this, right? Like if we wanted to find the A, we got our capturing group with just a simple A, and we would do a backreference, which is a \1, but in Java, of course, we have to use the escape sequence for the backslash, so it's a double \1, okay? Or if we wanted to find a couple O's together, we would do it that way, or I's together. Now we can also simplify the regex by using the //w metacharacter, which is basically a predefined character of all the letters A through Z, both upper and lowercase, also any digits 0 through 9, and an underscore. So we can make our capturing group with the regular expression inside of there of //w and say we want to find all repeating occurrences of that. Now, I haven't gone into what this //1 is, and now it's time to do that. So this is how a numbered backreference works. You have your capturing group followed by, and then here's where your backslash syntax comes in. //, and then the number, okay? Now, the number of the capturing group that you want to backreference, in other words, search repeated values, must match the automatically assigned capturing group number. So for example, in this regular expression where we've got capturing group //w, which is basically any character or digit for all, letter or digit for all intents and purposes. If we want to find a repeated letters or numbers or an underscore, right, we can just simply do //1. Now that one has to match this because that capturing group will automatically get assigned that number 1 there, okay? And that will find the PP and the OO and the LL. So anyway, moving on. This is how a named backreference works, right? You'll have your named group followed by a //k and then the name. So the name group that you want to backreference, in other words, search repeated values, will be prefixed with the //k and then the group name inside of chevrons, right? So in other words, here we've got a regular expression with our named group right here, and there's our naming syntax there. Question mark, and then test inside of our diamonds or chevrons, and then basically any letter or number there or underscore. And then to say that we want this named group to repeat, we have to use //k, and then inside the chevrons put the name of the group, okay? All right, now I can best explain a lot of these concepts with source code examples, so let's go ahead and come down here and do that. Let's highlight all this source code. Control C to copy, or right click and select copy. I'm gonna move my browser off screen, and I've got a shortcut to the command prompt on my desktop, but if you don't, you create one really fast by right clicking, selecting new shortcut, CMD next, and finish. It's just that easy. Let's go and open that up. If you're new to my tutorials, the first thing you want to do is type in javac, which is a Java compiler command. You should see all this stuff scroll by. However, if you receive an error message, watch my tutorial on installing the Java Development Kit. I'll make sure you get that installed and configured properly before continuing. CLS to clear the screen, CD space /, CD is short for change directory, / tells it to go to the root. We'll make a directory here called Java with the MD command. I already have that folder, but if you don't, I'm going to go ahead and create it for you. We'll make another directory here called Regex Backreference. And change directories to that. I'm on Notepad, Regex Backreference .java. It's going to be the name of my source code file, also known as a compilation unit. Let's do Control-V to paste that in there. Or you can right-click and select paste, whatever your preference is. All right, come up here and save that. First statement, I'm just basically importing the Java util regex package. Got my main method entry point inside of this single class here. First statement, I'm just creating a matcher type reference variable m, setting that equal to null, and I'm going to be doing these 5 lines, basically repeating them a lot throughout this demonstration here. So we're going to go line by line here. First thing we're going to do is just clear the screen. Let's go ahead and compile this guy, and let's run him, and then we'll come back up and take a look at the results and go statement by statement. Okay, so the first thing I'm doing, I'm compiling this regular expression here, pp or oo or ll, right? And then I'm invoking the matcher method on this particular search string here, apples, bananas, and tootsie rolls. Okay, and you can see, and then of course displaying to the console that basically that literal string literal there of the regular expression, and then invoking the group. You actually see what the find results are, pp, oo, ll. So this is like very, very basic, right? Extremely basic. There is absolutely no referencing, no capturing groups going on in here. All right, so let's just take it up a notch here now on the next thing we want to do here, and that is capturing group. This is capturing group number 1. It just contains a single character p in it. This is capturing group number 2 and capturing group number 3, okay? And then let's see what happens when we do that. So basically we get all that stuff there. And you might be going, okay, do these numbers really matter? In other words, can we do 3? Can we do 2 here, right? Let's just go ahead and see what happens, shall we? I always like to do that. All right, let's scroll back up here and see what sort of results we get, okay? All right, so here is where we were at, right? And as you can see, by changing these numbers of the groups and putting the numbered back reference right after the improper one, because of course we know this will be group number 1, this will be group number 2, and this will be group number 3. By mislabeling our references, as you can see, the only one that we get is the double P here, which is the only one that's properly labeled at that point in time. So as a matter of fact, labeling these things in the order that they occur does matter when you're talking numbered back references. Named back references, doesn't matter what order you do it in there, as long as you know you do it at whatever point but it'll make sense later on there. Let's just keep moving on this. All right. The next thing I'm going to do is, let's say for example we got this named group right here, and inside of there I've got a character class with the range lowercase a to z, right? And so this capturing group, I think I just said name group, this is a capturing group, and then of course we've only got one capturing group in here, so this will match that. So on that particular result, actually let's come up here and save this, let's recompile everything, get kind of our old stuff back there, right? And let's see, right up to here, right? Okay, so on our A through Z, and it looks like I'm just missing in the output there, but anyway, A through Z on that, well, I'll just make it right. Only takes 2 seconds. Okay, there we go. That's just the display anyway on that string literal. So by doing this particular capture group there, and then we say putting in the //1, right? We are going to basically get PP, OO, and LL. All right, so now let's kind of take that one step further, and in the capturing group, we'll just simply specify the predefined character lowercase w, and of course our back reference, numbered back reference 1, right? And of course we get the exact same result there. Now of course you'll notice in the output display we're only getting the single backslash there, and that's of course because of escape sequences. And if you don't really understand escape sequences, I have a whole awesome tutorial on that. At least that's my opinion, and that it's awesome. But anyway, a good tutorial on escape sequences too, so you can watch that as well if you're not fully understanding that, because that becomes really critical. If you were to look at like documentation and let's say for example, up on this one right here, you only put in like a /3 and a /2, right? Well, guess what? That isn't going to do jack squat, okay? I'll show you what happens when that comes around and you compile that there, right? As you can see, the only one here, and of course I didn't take the other slashes out of there, but you can see the regular expression that it compiled there. The only one that worked was the one with the //1, right? These did absolutely nothing, okay? So just you want to be aware of that, especially when you're naming or you're doing your back references there, double slash. So this, ordinary regular expressions, which are supported by a bazillion other languages, you'll just see the single slash in there. All right, let's see. Let's move on to the next thing here, and that is that's basically this. Down here, we're going to use the named one there, right? So I'm doing basically essentially the same thing right here that we just went over there, and only we're going to name it there, right? So there's our named group now, and then calling it there and saying that we want to repeat it, our back referencing, we do //k test, okay? And so you can see the results of that right there. We got the PP, the OO, and the LL. All right, let's go ahead and scroll up here a little bit more and kind of take it up to the next level here. All right, so up until now, we've just done single characters, and that's all well and good and not too difficult. But what if, for example, we wanted to match double characters, right? Let's say, for example, you see over here in bananas, here we got an AN and an AN and an AS, right? Well, the AS isn't part of a repeat pattern, but the A and the N are, right? We could do something like, for example, we could have something up here, right? Like AN, right? That would work out perfect for finding this bananas like that, right? But of course, since we're doing stuff, we need to understand how this would find not only this pattern, but if we had another repeating pattern in here, matter of fact, let's make a repeating pattern here like yo-yo, right? Okay. So what we can do is we can basically take, and I could have done //w//w here, but instead I just chose to use the character class with the range A through Z lowercase, followed by another character A through Z, right? Okay. So when this thing is cruising right along, it says, oh, here's a lowercase one, here's a lowercase one, right? Are there any other groupings? Because this is a group at this point. It's a captured group. So here we have a couple of characters. Are there any other PPs in here? And the answer is no. So we're not going to return anything back on that. So let's just come up here and save this since I added in yo-yo and compile this and come up here and show you our results there, right? So by using this back reference on this capturing group, we get AN and yo-yo right there found. So that's basically how that works there, now that we're taking it up a notch or two, okay? All right, let's talk about some other things, and as far as like nesting them too as well. And I won't confuse you too much with that, but as you'll notice over here in the OO, we also have a couple of T's, right? If you look at this part of Tootsie Roll right there, we have OOs repeated inside a pair of TTs. Could we match a regular expression like that? And the answer is yes. Okay, so our first capturing group is going to be the letter T, okay? And our next capturing group is going to be the letter O, capturing group number 2. So we're going to tell this we want O's to be repeated, right? And then because this is nested inside of this, right? That's nested right inside prior to that the /1 numbered reference, back reference there, right? That basically means that we need a pattern of T's around a pattern of O's, okay? So that goes ahead and finds T-O-O-T, okay? So you can start to do some pretty cool stuff with this. And then so instead of actually, hard coding T and O in there, we could put in, the actual just, predefined characters, right? Predefined letters and numbers, lowercase w there. This would be group number 1. This would be group number 2. So we want group number 2 to repeat inside of a repeating group number 1, right? And of course, before that I added over here, the acronym for software as a service there too, just to show you how that would work there too. So by using that same exact regex pattern with the back references there, we get T-O-O-T and the S-A-A-S there, all right? Okay, so let's go ahead and talk about, oh yeah, one more thing before that. I just went ahead and did the named thing right here too as well, right? And I named them 1, and 2, right? And so basically we got capturing group, named group 1, literally spelled out 1, and capturing group 2, right? And then //k2, and then that will be that back reference, I guess we could call it, that back referencing there has to be enclosed inside of that one there too, right? And we get the exact same result up here too with the named referencing as opposed to the numbered back referencing. Okay. Now let's talk a little bit more about maybe some more practical usage. And I'm just going to, there's a lot of like HTML, XML, they're all markup languages, and they all, I'm sure you're familiar with it, but you've got like your opening tag HTML and your closing tag HTML. Closing tag always has a / right before the name of the tag, okay? So the name of the tag is HTML. Here's a body, right, and another body, and that's enclosed inside of these HTML things here. All right, so let's talk about this regular expression here first of all. So if we wanted to search for anything that basically would be enclosed inside of a less than and a greater than, right, or the chevrons, right, opening chevron, closing chevron, we would do an opening chevron, and then we'll do a character class, right? So basically we'll take anything, the negation symbol, except a closing chevron, right? And then we'll do a quantifier of 1 or more inside of that, right? So basically we can have 1, 2, 3, 4, we got 4 characters in here, right? And then after that little thing there, then we're going to finally want our ending chevron there. And that's why we didn't want this chevron in there. We wanted actually like 1 or more characters to be placed inside of there for our regular expression. Okay, so on that particular one there, it'll find HTML body / HTML. Okay, all right. Now I like to introduce various different things. Like for example, if you watched my introduction to quantifiers tutorial, you know that I didn't go over all the quantifiers there, and I said I wasn't going to because it just took too long, and then, I'd come back and revisit it at a later tutorial, which I'll be doing shortly. Greedy quantifiers, reluctant and possessive at some future junction here. But anyway, what I'm doing is I'm using this search expression, and the only thing you'll notice that's different about it is the quantifier 1, comma, and then to infinity, right? Well, the shorthand method of that is using the plus, okay? So that is identical to this, and I'll show you the result on that up there. Let's go ahead and pull this out here. Okay, so the plus you can see, HTML body HTML, okay? Now the purpose of this tutorial, of course, is not to show you how to parse up HTML or XML or anything like that. Maybe I'll do a tutorial on that in the future, maybe not, but I'm just getting into the very, very nitty-gritty on matching stuff here, okay? So we've got our initial matcher there, right? But if we want to find a whole entire pattern, like everything in between this and this, right? Then what we'll do is I'll put the dot character in there, right? And the dot character basically encompasses every character but a line feed. Now you'll notice all my HTML is all on a single line, but if you were parsing out an actual HTML file, you would want to go ahead and with the pattern.compile command, you'd want to use the overloaded version of it, right? And do pattern dot, and I think it's .all, right? Is the flag to say that will then make the dot even reflect line feeds or carriage returns and line feeds across that, okay? But don't worry about that, just keep that in mind there. But anyway, so after our initial regular expression, which will find this, then we're going to do dot, and then I'm going to do a quantifier 0 or more, right? And then after we've done that, we need to basically have our left chevron, our /, same sort of syntax, right? Negation character on the closing one, right? And then plus, which is the same thing as 1 or more, right? And then our closing one out there, right? So here's what happens when we invoke that particular one. We get the whole entire thing with our closing one of HTML, our opening HTML, and our closing HTML. Now what I'm going to show you here real quick is is like, for example, I'm just going to spell this wrong here, right? And actually, you know what? No, I'm going to do that on the next one because I haven't put in a capturing group yet. But I'll show you what. No, never mind. All right, so on this next one here, and the final one here, what we're going to do is we're going to add in a capturing group so that we know we're going to match up the HTML with the HTML, right? And the body with the body, okay? Now, we'll do that by enclosing the actual meaty portion of it there, right? Which is, everything inside of our opening and closing chevrons. We'll make this a capturing group right there, which is basically any characters except for that closing chevron, right? And so that's our capturing group number 1 right there. And then we're going to put dot and then star. Now star is the same thing as the 0 or more quantifier, right? That's the shortcut for that, okay? And then we're going to have our closing chevron, our /, and then we're going to put in our back reference that refers to this. So in other words, our next repeating pattern has to match in here, okay? So our first repeating is HTML, our next repeating one is right here. But of course, you can see here's the opening chevron /, right? And then there is our second repeating pattern of HTML followed by our closing /. Okay? Now we'll get this as our result on that. Now what I want to show you here is, let's say for example, I was to misspell the second group, right? And make that just HTL. That doesn't match our first one, so there is no repeating pattern at this point. So let's go ahead and come up here and save this. Let's clear our screen. Let's recompile. As you can see, the HTMLs didn't match anymore, but guess what? The bodies do. So now it went ahead and said, oh, okay, hey, this pattern, right, is not closed out, but hey, guess what? Body is in fact a matching pattern there on that. So it went ahead and found that. All right, so I'm just going to go ahead and get rid of this and get rid of that and leave you guys with some final thoughts here now. I just want to reiterate that backreferencing is all about repeating patterns. Now, if you found this video confusing, that's good. That means you're learning, frustrated. I always say, if you get frustrated and you're confused, you're just learning. Your brain is processing stuff. Sometimes it's best to wait a day and watch it again. Things tend to sink in more. But anyway, that concludes this tutorial. Thanks for watching.